All right, congratulations on making it through Unit 1 finally. Welcome to Unit 2. Unit 2's pretest is a little bit longer, so obviously there are more of these. I'm probably going to cut this into 4 videos and do baby steps. So if you notice with the first pretest, my concepts and how they showed up are definitely not in any kind of order, but they were all there. So if you're kind of keeping track of, I did this one already. I've done this one twice already. Some of the ones that are like, go back and review this concept or whatever. So you're going to see some of that here. So we'll go through 10 or so. Kind of see, I don't really want this video to be too terribly long. So, all right, here we go. Unit 2 is really all about graphing. And so here's concept number 1. One of the first things they want you to know is like the difference between a function and not a function. And we'll go over this again later. We got some other examples, but a function basically, as long as each domain, each x value gets one range, gets one y value, like here in blue, I have 1 and then 2 and then 3, and it's actually split up here or whatever. As long as each of these domains only has one y value attached to it. So like this, where I have x show up multiple times, this would not be a function. So if x has multiple domains, it's not. So a function, each x has exactly one y. Now it is possible for, let's say if I had another one down here, for a y value to have multiple x's, that's actually okay, but you cannot have an x with multiple y. So each x gets exactly one y. Concept number 2. Again, y depends on x. X never repeats. So it could say distance depends on miles per gallon. How much you're going to spend depends on how many hours you're going to work. If x never really changes, like it just stays the same over and over and over, then it's not a function. And it could be weird because x and y could potentially switch spots and then you would be a function. But if x never changes, then you're probably not looking at a function. It's usually just a straight up and down line. So be on the lookout for, something depends on something else. It's generally a function, and it's not a function if x never really changes. That's concept 2. Concept 3, just getting kind of the overview of domain and range and input output and cause and effect and x and y, and the order you do this is always alphabetical. Domain is your input and x is your input. Like when you have a y equals mx plus b, you always plug into x and then figure out y, unless for some reason you're working backwards. But your input is usually x and your output and range, that's usually your y value. So there's concept number 3, just kind of making sure you know the difference. They're always alphabetical, x and then y, d and then r, I and then o, c and then e. So when you write them like in a xy pair, it's always xy. Because if they use a and b, a then b. If they use s and then t, it's s and then t. So it's always alphabetical. Concept 4, what can my domain be? Well, it just depends on what all you can do with x. A lot of times you can plug in whatever you're looking at into like y equals on the calculator and kind of figure out like, okay, well, x stopped here, and you can go to the table and see what's happening. Can I use all numbers? Well, imaginary numbers are included in all numbers. Usually you can't select all numbers will work. All real numbers, once they throw in the word real, well, perhaps if you have just a simple y equals mx plus b, you can probably substitute any x value in and get out some sort of y value. Because remember, that's what domain is, our input. Can I have 0? Well, not if you're dividing, because if you divide by 0, then you get an error. So if you have something like this, 2 minus 2 would make 0, so x actually can't be 2, but it could be literally anything else. It could be 2.1 or 1.9 or anything like that, because the bottom will be some sort of decimal, and we can work on that. Same thing here. I can do 0.1 or whatever, because it's not 0. I can divide it and get an actual number. So if you're dividing, then obviously you can't divide by 0. If you have something like this, just make sure, oh, well, if I plug in 2, that makes it 0. Can't do it. Only positive or negative numbers. Most positives are okay. Negatives, you got to be careful, because you cannot take the log of a negative number or a natural log. That's the ln, little curved L. So log and natural log are kind of the same. You cannot square root a negative number either. So on this one, you can't have negative, or on this one, you would have to say, look, since 0 and 1, and even like 1.5 would make this a negative number, x has to be bigger than or equal to 2. Same thing here. X would have to be bigger than or equal to 2 to make sure this stays positive. So just make sure you kind of figure out, okay, if I'm square rooting, I just can't have that negative. So if it's something else in there, figure out how to keep that bigger than 0. Concept 5, talking about range now. Well, what kind of outputs are we looking at? And I'm going to use the graphing calculator for this, so I'm going to do a little bit of pausing as we go. What kind of outputs will y equal x spit out? Well, y equals x is our line right here, and if you go to the table, you can kind of arrow up and down, and if you go far enough both directions, you'll actually be able to see that there's no limit on y, there's no limit on x, because they are equal. Anything I can plug in for x will spit out a y. So this actually gives us all real numbers for x. For y equals x squared, graph looks like that. And what kind of outputs will we have? Well, if you notice, I don't have any down here. Let me zoom. I don't have any down here, which means my y value, my output, will have to be either 0 or greater. And if you go to the table, you can see we get down to 0, but we don't have any negative numbers with x squared. The graph tells us that, and the table tells us that. So you would say y has to be greater than or equal to 0. What about square root of x? Square root of x looks like this. Well, that's kind of weird. First of all, we don't have any x values here, because if you remember, I cannot square root a negative number. So that's why nothing is over here. And when you square root, there's nothing down here, because you can't square root something and get a negative number. Now, you may remember from other stuff, plus or minus or whatever, and if I went back here and I put the negative there already and did square root x, it would show that part of the graph. And if you notice, this and the y squared are the same type of graph, but for just the square root of x, you actually have to be, and if you go to the table again, you have to be bigger than 0. It actually gives you an error saying it's just not possible. Not possible to get really any kind of answer, but you also notice, well, that's because you can't plug in an x, so there is no y to go with it, and our graph showed us it's all positive numbers. Ooh, I took out the negative is what I did. I didn't clear the whole thing. So that one is the y equals x. 1 divided by x, the graph looks like this. So, well, it looks like this is going to go down. And if you know anything about this, this goes that way forever, this goes down forever, this goes up forever, and this goes right forever. The only problem is the one number you cannot have is 0. We will never get to 0. This decimal will get smaller and smaller, and that decimal will get smaller and smaller. We're going to get closer and closer to x equals 0. Which also means, so x equals 0 is not an option, and this will get smaller and smaller, and this will get smaller and smaller, but we'll never have y equals 0 either. So on the 1 over x, obviously, I can't divide by 0. We already know that. But because 1 divided by something will always spit out something, just never 0. So what about log or natural log? Those graphs are similar enough, but they are a little bit different, just kind of based on the log. You can, though, see they are kind of like our square root graphs, where we can get a y value of 0, but we cannot get anything negative. So on our graph, you can see, well, let me, hold on, I'm so sorry. These start, and it's really tough to see. These really start approaching this 0, but it never hits. So actually, if you look at smaller numbers, we can actually go into the negatives a little bit with log and natural log. And even if we zoom in some more, you can see we can actually get super big negatives with super small decimals for here. So we actually can go all the way down. We just can't ever have an x value of 0. So we can go as far negative as we want. We just have to be super, super small on the fractions, and then of course our y. So with log, we can actually have all real numbers. Now this e to the x is a fun little graph because it does this, and well, it looks like it bottoms out here at 0, but again, since we can't ever really get to 0, as we do this, we're going to get closer and closer and closer, and this is times 10 to the -4, which is scientific notation. We're going to get smaller and smaller. So with e to the x, y will have to be bigger than 0. We cannot get to 0, even though it looks like it. So our outputs, our range would be y is greater than 0. And that's kind of all the different ones. There's a few more, but this is probably all you'll need for this. Concept 6 and 7 kind of go together. We'll do this, and this will be the last one for this. When you do notation, if you know you're not equal to, then you use parentheses saying like, oh, I can go from here to here. If they are equal to, you use brackets to say like, I'm going to include this number. On here I'd say, I can't use 2, but I can go all the way to that number before 2 doesn't work or whatever. If the graph stops going, like if, oh, well, it looks like it was going to keep going, and then maybe over here off the graph, it looks like it was going to come back. Well, since we don't know anything past that certain point, we would claim that point if it's good and put a bracket on it. We can't see what's happening, so we can't make any guesses, which is a little weird. But if you can follow the graph, it says, well, you know, what months are we going to be selling more than, you know, $500? Well, if we have like this curve or whatever, we kind of figure out, oh, boom, that's where we start, and oh, the graph stops, so I'm going to go from this number to the end of the graph. That'll get you through the first 7 concepts. My videos can't be too terribly long, so I'm going to stop here and upload this and start on the next video.